Hello everyone, I'm going to talk about function graph tracing. So this will be probably the last video in the series about ftrace, where I teach you how to follow a certain function through all the calls that it makes. And that's a very, very cool technique. Sometimes you do it because you want to understand, let's say, the latency of a function, right? And what, let's say, what part of the function contributes most to the function latency. Sometimes you do it because you just want to know what the function is up to, right? We're in this path that includes the files for configuring ftrace. And let's look at the available tracers. And what we're interested in is the function graph tracer. So what I want to do is echo this function graph tracer into the current tracer. Okay. And then look at the current tracer. Now I'm using the function graph tracer. Okay, so let me just turn off tracing in case I'm doing it. Okay, let me just empty the buffer. Trace buffer is emptied now. So we're gonna be doing function tracing. So these are just generic functions in the kernel that we're gonna trace them. But we're gonna show the function call. Now, there are a certain number of filters here that, well, you can't really start tracing every function and then all the sequence of function calls that it makes, right? As in a nested way, because it's just going to blow up your system. So with function graph tracing, you have to be very, very careful about how you set your filters. And these are the filters: set graph function and set graph no trace. Okay. So set graph function, what it does is that it would, like, you specify a function here and it would only trace that function and all the functions that that one calls. And if you put anything in set graph no trace, it would not trace from the moment that it enters that function until the moment that it exits. So let's say you want to trace function f1, which makes a call into f2 and f3, but you don't want to trace f3. So you would put f1 into this filter, into the whitelist, and which would automatically then mean that f2 and 3 would also be um, traced, right? But since you want to blacklist f3, you would put f3 here. Okay, kind of makes sense, I guess. So let's just try this out. We already had like a TCP v4 something function from a previous video that we were looking into, and it was this function, TCP v4 receive. What I want to do here is I want to know like what this does exactly. I want to trace this function, which is called when a TCP packet is received. So what I'm going to do, well, first I need to check if it's among the available filter functions. So I'm just going to say grep TCP, well, grep this guy. Yeah, it's there. So what I'm going to do is I'm going to say echo this into TCP graph function, and then I'm pretty much done. Now I'm just going to turn on tracing, 1 and 2 tracing on, and yeah, that's it. Now I'm going to turn off tracing. Hopefully we've had some TCP packet being received. Hopefully, we'll see. Now I'm going to turn it off. Now I'm going to say cat trace, because this is the trace buffer. And then I'm going to pipe it to less so I can scroll it. Well, this is halfway. This is kind of maybe probably halfway there. But there, yeah, this is it. See? This is the TCP v4 function. I've entered the function here. And, oh, by the way, this is the CPU core under which these functions are being executed. Um, so I'm entering TCP v4 receive, and then here I'm leaving it. And this telling me is that this took 35.172 microseconds, right? And the plus sign means that they're actually, these are defined in some way here. So let me just show you. Yeah, so these are just, plus means that the function exceeded 10 microseconds, exclamation mark means exceeded 100 microseconds, and then the hash is 1,000 microseconds, and so on and so forth, star, and then this, and then that, right? At sign. So these are just, what do you say? Like these are um, these are defined this way. They don't really necessarily mean anything, right? Now, 100 microseconds could actually be very low in a certain part of the kernel. If it's like a very big function, that could be completely fine. So know your function and look at the actual number, right? But yeah, that's what these means. Okay. So TCP receive v4 is actually calling TCP v4 inbound MD5 hash, which then calls TCP parse MD5 sig option. And this function took 0.4 microseconds. And then this guy, right? So we get the time, the total time at the point of exit from that function is 1.6. And this is inclusive of the 0.4 microseconds, right? Fill callback, TCV4 do receive, and so on and so forth. So if I go, let's just try to match this with what we have here. See if that makes sense. Okay, so the first thing, well, maybe this translates to a function, I don't know, but TCP/4 inbound MD5 hash. Actually, let me see if we can find something like that. Well, maybe it's somewhere here. So it's a define, right? And okay, one thing to note is that sometimes you may not see all of the functions here. So in this case, PSKB may pull. We didn't see that, right? And the reason we didn't see that is because if you looked at this function, right? This function is defined here as a static inline function, right? So it's inline. Inline means that this function is compiled in place. It's just a macro, right? So have that in mind, that you're just gonna see the functions. So what else? TCP v4 inbound MD5 hash. So let's see. There you go. It's here. See? There you go. That's the first one. So I'm still in TCP v4 receive, and here I hit this function call. Okay. What else can we spot here? So if TB, this is also again a macro. This condition. Okay. So yeah, here. Look at this function. See, this function is supposed to show up because it's not a inline function, right? I'm supposed to see this function, inet csk whatever, but I don't see it here, right? That means that this function was not executed. And you know what that means? It means that this condition was false, was never true. So this is actually a good thing. Now you can understand why I would do a function graph tracing, right? Because it tells me that, oh, in this case, this condition was not true, and maybe that makes sense, or maybe that's a bug, or I don't know. Like, um, and by the way, I forgot to tell you here that the tracer is function graph, and you can see that. And another, like, I don't want to bore you with all of this, by the way, but see, another thing here is that whenever there's a context switching happening, I'm going to get the context switch events. So whenever, let's say, it's basically doing its tracing, right? And then all of a sudden there's a context switch happening um, from the ALSA, whatever process to the idle process. So it just mentions it there because then you have some information about the context under which this whole thing is running, and maybe that is relevant or irrelevant depending on what you're really doing here. But whether you ask for it or not, ftrace is going to put context switches here for every CPU. Okay, so this is another case of TCP/v4 receive, and so that's, we actually hit two cases, both happening on CPU 12. Okay, that's it. Now, um, we can actually add to this information a lot of things. Sometimes the function you're tracing is very long, so you kind of lose track of these curly brackets, right? How they match each other. So what you want to do is basically you want to say here, okay, so please put a comment here saying that this is the end of TCP/v4ac, for instance. You're actually able to do that. There are a number of trace options, and we also talked about these. So cat trace options. There is something called annotate. Yeah. Oh, actually, okay. Let me just go here to the documentation because I always forget about what this means now. Trace options, print parent, not for function call tracing, documentation. Yeah, okay. Yeah, annotate is not this. Annotate is basically for providing this information. So we already have that. Um, yeah, not here. Oh, okay, so these functions were available options. Okay, these are available options per tracer. So this is for function tracer. Okay. Oh, okay. There you go. For function graph tracer. Um, well, this gives you the CPU. We already have that. You can see func graph CPU. We have it. There you go. Func graph CPU gives you the CPU. Func graph overhead. We already have this. We don't have the func graph proc. It doesn't tell you what process was running, but it's okay because I do have the context switch information. Yeah, there you go. This is it. Func graph duration. Oh, we already have this as well because this gives me the duration of the function at the exit time. Oh, and if you want to put absolute timestamps, then this is a good thing. And sometimes you want to put absolute timestamps because you want to correlate this with an event trace where it has absolute timestamps. Oh, this is it. Yeah, that's the one. Func graph tail. This is the one. See, I have it as no func graph tail. So what I want to do is I want to echo func graph tail into trace options. And if I do cat trace options, you can see here I have func graph tail. So now what I want to do is I want to enable trace. Let's just first clean the trace buffer. Okay, screen, start tracing on is enabled, then stop it. Just give it a little bit of time to kind of collect something and then stop it. And then cat trace less. Yeah, this is it. So as you can see, TCP/v4 receive here. Here I have at the end, it's got this in comment. So I know where each function ended. So I know here this function ended here. For instance, TCP/v4 receive was started here, and so on and so forth. Okay, and then that's kind of cool, right? What else? Yeah. So TCP/v4 receive here. Look at that. So this is pretty large, right? And then it kind of ends here. Okay. Okay. So this is kind of nice, I guess. Um, what else? What else? Let's try something out. Okay. What I want to do is I want to just enable an event here as well. I just want to say echo one into events, and so there are these SKB events, and I want to enable all of them. These are for socket buffer events. And also the sock subsystem for all the socket. These are layer 4 sockets. Okay, I want to enable these. So I want to do both event tracing and function graph tracing at the same time. Although I had it set to like the tracer type is function graph, but I'm just going to try this out. So let's empty the trace buffer. Let's put tracing on. And wait a little bit and then tracing off. Go ahead, trace less. And by the way, you can copy this guy over somewhere, but I just, I don't want to save this. Okay, see, that's something, huh? So you can see actually that these events show up as comments, like, kind of like comments, right? It says SKB copy datagram, SKB address. This is just like the events, but it's shown in a different format. Consume SKB, this is the event argument. And then, well, obviously no function was being, like my TCP/v4 receive function was not called here. So this is also the context switching. So let me just search for that. TCP/v4 receive. Yeah, there you go. See? So I have a consume SKB, and then TCP/v4 receive, and then this whole thing, right? And then, when this happens, like I also have another consume SKB before that. So apparently there is something to do. Whenever I consume an SKB, I probably give it to the TCP layer. Well, in this case, the SKB, the SKB is a buffer that holds packets, IP packets. Um, that must have been a TCP, because then whenever I consumed it, I gave it basically to TCP layer, right? Yeah, and then this is actually quite cool, I guess, right? You guys probably like it. But the thing is, it doesn't have a timestamp. So what I want to do is I can add a I'm going to add this function, which is I'm going to add this option, which is what? ABS time. Funcgraph, yeah, funcgraph absolute time. And I'm going to say echo. Okay, so cat trace options, this is it. It says no function apps time. I'm going to say cat, yeah, funcgraph apps time. Put it in trace options. Options. Okay, so now, well, I have it here. Again, clear up the trace buffer. enable tracing, and then tracing off. Okay, cat trace less. See, we got the timestamps. These are the timestamps. Okay, and let's look for my TCP v4 receive. Just going to search for it, and then you can see that I do have both an absolute timestamp and the latency, right? Because I have both. I have both this function set and sorry, this option set and this option set. Okay, this is something really, really cool. So you can actually have all the events at the same time as all of this and understand what's really going on in the system.